Hello viewers, this is Ronald taking you through the tutorial for A-Level Applied Mathematics. And this video we're going to talk about the questions on motion on inclined plane involving force parallel to the incline. And this topic is still on mechanics and is suitable for students in Senior 5 and Senior 6 offering principal mathematics as part of their combination. Now these are the very questions I left in the previous video, so I believe by now you already tried them out and ready to mark yourself and check your progress. So we shall start with question 1. Question 1 came from UNEB 1999, paper 2, question 6, and it says a box of mass 4.9 kilograms rests on a rough horizontal plane inclined at an angle of 60 degrees to the horizontal. So this word was not supposed to be there, so you remove it. If the coefficient of friction between the box and the plane is 0.35, determine the force acting parallel to the plane, which will just, know that word, just move the box up the plane. So just this word, just move the box up the plane, means that the box has not yet moved up, but it's at the point of moving up the plane. So always know that word, that when there is the word just, it means it is about to start. So the first thing to do is to make a sketch of what is given. The total of the angle is 60 degrees and the particle is of mass 4.9 kilograms. So we are going to put here the weight of the particle as 4.9 g. Then we have to resolve that weight parallel to the plane to give you 4.9 g sine 60 degrees, and perpendicular to the plane to give you 4.9 g cos 60 degrees. Then you also have to put the normal reaction capital R. So the particle is at the point of moving up the plane. So they said that the force is parallel to the plane, so this is the force which is parallel to the plane, and the particle is at the point of moving up the plane. What does that mean? It means that acceleration is 0 and the friction will be in the opposite direction, which is mu r. So after drawing the sketch diagram, next will be to resolve. Now when I resolve perpendicular to the plane, I realize that r is equal to 4g cos 60 degrees. So g is 9.8, therefore r is equal to 24.01 newtons. The next will be resolving parallel to the plane. So parallel to the plane, these two forces will be equal to this force, because this acceleration is 0, therefore this minus this is equal to 0, implying that F is equal to 4.9 g sine 60 plus mu r. So when I substitute, I'll come up with mu is 0.35, which was given in the question, and r is 24.01, which was already got, g is 9.8. and acceleration is 0. So with that, I'll come up with my force being equal to 49.990 newtons. So basically that is what they wanted. Now let's see how much can be awarded. So B1 for the correct force diagram drawn using a ruler, B1 for normal reaction, M1 for left hand side, and another M1 for right hand side, then A1 for the force. So basically that's how the 5 marks would be awarded. Now we shall go to question 2, which came from UNEB 1997, paper 2, question 6, and says a box of mass 2 kilograms is at rest on a plane inclined at 25 degrees to the horizontal. The coefficient of friction between the box and the plane is 0.4. What minimum force, note that word, minimum force applied parallel to the plane, now that word parallel to the plane, would move the box up the plane. So here they have not put there the word just, but they've just told us that would move the box, but they have given us the word minimum, meaning that it is at the point of moving up the plane, just about to move up the plane. So when you see this word minimum, is the same as just. So the first thing to do is to place our particle on an inclined plane, which is inclined at an angle of 25 degrees. Then after that, we have to remember that the mass is 2 kilograms, therefore the weight will be 2g acting vertically downwards. Then the component of that weight parallel to the plane will be 2g sine 25 degrees. And the component of this weight perpendicular to the plane will be 2g cos 25 degrees. Then we also have to put the normal reaction, which will be capital R. Then you also have to put the force. They said minimum force, so it will be F min to mean minimum force. So the point of moving, so that means that acceleration is 0. Then they also told us that the plane is rough, so friction will be mu r. So I think we have shown all the forces acting on the particle. Next will be to resolve. So when I resolve perpendicular, I'll come up with r being equal to 2g cos 25 degrees. When I simplify, I'll come up with r being equal to 17.7636 newtons. Then when I resolve parallel to the plane, I realize that these two will be equal to this because acceleration is 0. So I'll come and say that F min will be equal to 2g sine 25 degrees plus mu r. But the good thing, I know my mu is 0.4 and r is 17.7636 and g is 9.8. It's a constant. Therefore, when I substitute, I'll come up with minimum force being equal to 15.3888 newtons. So basically that's what they wanted, and now let's see how much can be awarded. So B1 for the correct force diagram with all forces shown and drawn using a ruler, B1 for normal reaction, M1 for this component of weight, and another M1 for friction. Then A1 for the output. So basically that's how the 5 marks could come about. Now we shall go to question 3, which came from UNEB 1989, paper 2, question 4, and says a particle of weight W is at rest on an inclined plane under the action of a force P acting parallel to the line of greatest slope of the plane in an upward direction. Know that word upward direction and parallel. The angle of friction between the particle and the plane is lambda, and the angle of inclination of the plane to the horizontal is 2 lambda. Show that P max, or the maximum force of P, is equal to W tan lambda multiplied by 4 cos lambda minus 1, and P min, or minimum force of P, is equal to mu W respectively. So mu is the coefficient of friction. Now the first thing to do will be to draw a diagram, force diagram. So for maximum force, it means that, so there are these two words, there is minimum force and maximum force. So maximum force means it's at the point of moving upwards, while minimum force means it's at the point of moving downwards. So not those two words. So now for maximum force, the particle is at the point of moving upwards, so we have to first know the weight. Weight is W, so we shall put it there, acting vertically downwards. Then the component of weight per the plane will be W sine 2 lambda. and component of weight perpendicular to the plane will be W cos 2 lambda. Then the normal reaction will be capital R. Then they talked about this force P. It is parallel to the line of the greatest slope and acting upwards. So we shall come and put our P max there. Now because it is maximum, it means that the particle is at the point of moving upwards, therefore acceleration will be in the upward direction, but it will be 0 because it's not yet moving. And because it is at the point of moving upwards, friction will be acting downwards along the line of greatest slope, which is mu r. Now before we go to the next slide, so B1 will be for drawing a correct sketch diagram with a ruler. So now next will be resolving. So when I resolve perpendicular to the plane, resolving perpendicular to the plane, I'll get R equal to W cos 2 lambda. So I'll come here and say that R is equal to W cos 2 lambda. What about resolving parallel to the plane? Now when I resolve parallel to the plane, P max will be equal to W sine 2 lambda plus mu r, and that is because acceleration is 0. So I'll come here and say P max is equal to W sine 2 lambda plus mu r. So r is 2 cos lambda, and mu is the same as tan lambda, because they told us in the question that lambda is the angle of friction, and remember angle of friction is arc tan mu, where therefore when I make mu the subject, it will be tan lambda. So when I substitute that, I'll come up with W sine 2 lambda, and tan, where there was mu, I put there tan, which is there. Then this r, I remember that r is W cos 2 lambda, which is that. The next is to divide both sides by tan lambda. When I divide both sides by tan lambda, I'll come up with that P max over tan lambda, and this side will be W sine 2 lambda plus tan lambda times W cos lambda over tan lambda. That when I simplify, I will come up with, for example, sine 2 lambda is double angle, so half angle of this will be 2 sine cos, so it will be 2 sine lambda cos lambda. And this double angle of cos in half angle to become 2 cos squared lambda minus 1. The next is to split the numerator, so the whole of this divided by tan is the same as 2w, so 2w is this, 2 times this to give you 2w sine lambda cos lambda time divide by tan, so divide by tan you get cot, which is cos lambda over sine lambda. Then for this side, this tan will cancel with this tan to remain with 2w cos 2 lambda minus w. So before we go to the next slide, let's see the marks for this slide. So B1 for normal reaction, M1 for resolving, and M1 for substituting for mu, and M1 for half angle and dividing by tan. So in this case, previously we saw that P max over tan lambda is equal to 2w sine lambda cos lambda multiplied by cos over sine plus 2w cos 2 lambda, cos squared lambda minus w. So when you look at this, you realize that this sine, this and this can cancel, and this multiplied by this can give you cos squared lambda. Therefore in the end you'll come up with 2w cos squared lambda for the whole of this part, but there's also this 2w cos squared lambda and minus w. So that is where this step is coming from, 2w cos squared lambda plus 2w cos squared lambda minus w. Then this and this are common, have a common factor, so when I add the two, I'll come up with 4w cos squared lambda minus w. The next will be to cross multiply and factorize. So w is common, so when I pull it out and this term comes this side, I'll remain with, in the bracket, I'll remain with 4 cos lambda minus 1, and basically that is what they wanted us to prove for P max. As you can see it here. So this is the proof for P max. Now next will be the proof for P minimum. Remember we said for P minimum the particle is at the point of sliding downwards, while for P maximum the particle is at the point of sliding upwards. So now we are done with P maximum. Now let's go to P minimum. So for minimum force, we shall come and draw our sketch first and put a particle there. The first thing to do is to put the weight acting vertically downwards and the component of the weight along the plane and perpendicular to the plane. The normal reaction capital R and the force P minimum. Because this is P minimum, the particles are at the point of sliding downwards, that's why this acceleration is pointing downwards, but it is zero, meaning it has not yet moved. Because it's at the point of moving downwards, friction will act upwards along the line of greatest slope. So with that we can now resolve perpendicular to the plane. We shall come up with R equal to W cos to lambda. What about parallel to the plane? Parallel to the plane, we shall come up with this being equal to this plus that. So you come and say that P min plus mu R is equal to W sine to lambda. So when I substitute when I make P minimum the subject, this will go this side to come up with this. Now before we go to the next slide, let's see how mass can be awarded for this slide. So B1 was for this output, B1 for the correct force diagram, B1 for normal reaction, and M1 for resolving, which is there. Now we know that R is W cos to lambda, so we shall substitute there. Then we know that sine to lambda is the same as 2 sine cos, which is that, and cos to lambda is the same as 2 cos squared minus 1, which is that. Therefore, here when I open this bracket, I'll come up with this line, and when I remember that mu is equal to tan lambda, it implies that P minimum will now be equal to 2w sine lambda cos lambda minus 2w tan lambda cos squared lambda plus mu w. Now what I've done, I've substituted this mu, I've put there tan lambda, which is that, but for this one I've not, because in the proof they want this expression, so we have to look for eliminating this. Now tan lambda is the same as sine over cos, which is there. Here we have cos squared, which is that. Now when you look at this, you realize that cos and cos goes with one cos to remain with only cos lambda, and that cos lambda will be equal to, will multiply by this to give you sine lambda cos lambda. Therefore in the end we'll come up with 2w sine lambda cos lambda minus 2w sine lambda cos lambda plus mu r. Now when you look at this critically, you realize that they are the same but they are subtract, therefore meaning it is 0, and therefore in the end we'll come up with P minimum being equal to mu w, which is the proof they wanted. So yeah, M1 will be for half angles and substitution, then another M1 will be for substituting for mu, which is that, then B1 for the required expression. So basically that's how the 12 mass could come about. So what I'm going to do, I'm going to leave you a set of questions still on motion on inclined planes, but this time the external force is a horizontal force. So in the examples we have done, the external force was a parallel force to the plane, to the line of greatest slope. But this time, what if the external force is a horizontal force? So that brings us to the end of this video. Thank you for watching, and be reminded that the solutions for the assignment left will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on the solutions for the assignment left has been uploaded. Otherwise, thank you for watching, and also if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.